Greetings everyone, welcome to another video. This is my lab bench power supply that I built. In this video we're going to go through it, how I built it, why I chose everything I chose about it, how you can do it better. But for my needs, this is exactly what I wanted. Keep in mind, this is the first time I'm building anything like this. First time working with basically anything. It didn't come out perfect, but that's fine. So yeah, let's get into it. Okay, so I found this power supply in the trash. Actually, it was in a computer, but it's a Cooler Master 620 watt one. Feels pretty beefy, actually quite quality. But again, I found it in the trash, so might as well use it for something. So this is what I'm gonna use. Besides the power supply, I'm gonna need some other stuff. This is what I gathered here. I have a panel meter, volts and amps. USB socket would be good, and some various bits and bobs like banana connectors and a step down, step up power supply, so I can adjust whatever voltage I want. Okay, so let's get started. Before we get on to it, let me remind you that you are working with mains voltage and electricity, and this stuff can and will kill you if you're not careful. So please do be careful, unless you don't know what you're doing. So just, well, don't do it if you don't know what you're doing. So my plan for building the box for this power supply was to use these PVC sheets. I'm not sure they're PVC, polyurethane, I don't know exactly what they're called. Got them from the local hardware store. They were quite cheap, but they didn't have a lot in the same color, so that's why it came out looking like a rainbow, but I'm fine with that. Adds to the charm, I guess. So I started with this. It's easy to cut, very easy to cut with I'm just using a utility knife, but it's super easy to cut and work with, drill and everything like that. So I'm just winging it at this moment with this blue one, but of course that didn't go according to plan. While trying to make the hole for the fan for the power supply, I kind of screwed it up. I mean, I didn't exactly screw it up, I just didn't have screws long enough to reach to the blue sheet and through the mesh of the fan all the way, so it'll be looking nice. So yeah, I'm just struggling here to cut it, but it's easy to cut. So it didn't work out, so at some point I'm just gonna stop focusing on this and just cut out new panels to begin with. Yeah, so here we go, starting over from the beginning. That's why it's a new color now. I'm using a square to make sure everything is square. It didn't turn out square, but it's not too bad, to be honest, considering I cut everything by hand in just a piddly ass square that I found, and I'm not exactly sure if it even is that square. So yeah, starting from the beginning, just cutting it out. For the corners, I'm using bits of wood, which again I got from the home improvement store. Just regular, I think it's 2 by 2 centimeter square bits of soft wood, but they work just fine. And in order to secure them to the panels, I'm using a drill bit with a countersink, so everything is nice and flush with it, and just using normal wood screws, the thinnest and shortest ones I could find. Using some clamps to help me keep everything in position somewhat, and just screwing them down. Removing the top layer of protection was quite a challenge. I think this polyurethane sheets, whatever they are, were kind of old and sitting in the store there. Maybe that's why they were so cheap. So it was a pain in the butt to remove. I think I paid around $4 or something similar for a sheet. It was in 50 by 50 centimeters sheets, if I'm not mistaken. But yeah, quite a reasonable price. So once I'm done with the first layer, I'm just setting the power supply in its place, and then using some extra bits of scrap wood that I have to keep it in place. So to make sure it doesn't move around. It won't in the end since I'm using hot glue for it, but I just wanted to make sure. And I'm just securing it from the other side, again using some wood screws. In order to make sure I'm setting it up correctly, I need to put the other panel as well, where the access to the cable for the power supply and ventilation from that side goes. So I'm just measuring from the sides roughly where the holes for the switch and the power cable for the power supply goes in, and just roughly measuring, and then making sure it's straight and just cutting out the holes so I can have access to them. Once I make sure they're somewhat decently placed, then this is the first of many mistakes that I did. I just hot glued it down, forgetting that I have to cut up the hole for the fan. Got quite frustrated at this point. Yeah, but anyway. So I just unsticked it and then use a paper stencil to make sure I'm making the hole in the right place. Just use a normal sheet of paper with a pencil to determine where the holes for the fan would go. Just cutting it up. Placing it where the power supply would go, and just drilling out the hole. I use the biggest step bit that I have to drill out the holes, and then just free-handed the rest of it as I marked it down with a utility knife. Again, it's just for ventilation and not for looks, so I'm quite happy with it. And for the back side of the power supply, again, I'm using the same step drill bit to drill some holes. Cleaning it up, making sure it has enough ventilation. I'm not gonna use this power supply at its full rated power, but yeah, ventilation always helps. It actually, when using for normal low power stuff, the fan barely even spins up. You can barely hear it. So yeah, once that's set in place with some hot glue, I'm continuing with the rest of the sides of the box for it. Just drilling and screwing as I go along. Here's another angle how it looks like while drilling the holes and screwing it in. Also where the ventilation holes and the power cable for the power supply goes. Using some small clamps just to keep things in place while I go along. Looks quite flimsy here, but once you put all the woods and all the panels together, it actually comes out quite strong. So last side, just measuring it in situ, cutting it up and attaching it. Now let's get on to the wiring. I'm going to use the green power supply on and one of the black cables for a switch to turn the power supply on. Remember, modern power supplies won't stay on unless they have a load attached. So I'm hoping, and it turned out just like that all the LEDs and everything else that I attached to it will put enough load to keep it on, and it does. So the green and the black to a switch to turn it on. Then I'm using some LEDs to indicate if it's on. I'm using the purple wire together with the black wire. The purple wire is for 5-volt standby power, and I'm using that with a 220 ohm resistor to show when it's plugged in. And then a normal the red wire, which is 5 volts, again with a black common or ground wire for when the power supply is on. I'm using red LED for standby power when it's plugged in, and green for power on from the switch in the front. Making sure everything is cut correctly, correct length, so it doesn't take up too much space inside. I left a lot of room for improvements and modifications later on. I'm referencing the datasheet for this panel mount 12 volt to USB adapter. Squaring it up, making sure it's in line somewhat and straight. Yeah, just plugging it in, just fixing it there and attaching the 12 volt, which is the yellow wire, to one of the common wires. Using heat shrink for everything. This power supply wire is for some reason very difficult to solder to and very hard to cut. I don't think it's copper, I think it's some kind of steel. Anyway, it was a pain in the butt to solder to, so whenever possible I just use spade connectors and twisting the wires together. Testing it, making sure it works. Here's the schematic and how I put everything together. Yeah, like I said, the green power supply on to one of the blacks, the green and the red LEDs with 220 ohm resistors attached. Then everything else goes to the banana jack adapters and as well to the panel mount USB power, which is always a good idea to have it there, charging your phone or testing whatever else you might have. Again, making sure it works, all looks good. And then continuing on to the adjustable. And now I'm mounting the step-up DC to DC converter that I'm installing together with a volt and amp panel meter. The module is based on an XL6019 DC to DC boost converter. It's rated for 5 amps, so I'm never going to use it anywhere near that. I'm changing the pot from the board to have it externally, since that little pot is very difficult to change. And I'm struggling a lot with my desoldering skills to change it, but I managed in the end. Quite a reasonable job. I'm not sure I used the correct pot for it. I think I used like a 10K, and the adjustment is not as fine as I would have hoped, but it's, with a little patience you get there. Not that important. I'm not quite sure I'm going to use it that much for voltage above 12 volts. I should have got a step up, step down converter, but maybe that's for the future. It's easy enough to change. Yeah, this is how I installed it in order to monitor the voltage and the amps running through it. Took me a while to get there, and the banana jacks for it as well. And now I'm mounting the banana jacks for all the other cables, just connecting them with spade connectors, buttoning it down, marking a line, making sure everything is somewhat in its place and looking symmetrical at least. Testing as I go along, making sure I'm not mixing up any cables. And of course I mixed one of them up, positive and negative, so I had to change them. Yeah, looks good. Now just buttoning everything up, putting the cables back. Final piece, final lid of the box going in place. Then cleaning up the pencil marks a little bit with some isopropyl alcohol. Cleaned up nicely. Then using my Dymo label maker to make some labels about everything. For all the voltages, what the switch does and positions and stuff like that. And here it is, fully working. Just giving it a once over, making sure everything is working fine with a multimeter. All the voltages are correct. Yeah, looks okay. This is a random clock DIY soldering project that I did. Just make sure everything works. Yeah, multimeter, everything looks good. And that's it. Here's a picture of it. Here's how it looks like. I'm really happy with it. I've wanted to build one for a while, and I'm really happy how it turned out. Again, it's a lot of room for improvement, but all in due time if I do need it. But for my needs, it's gonna be just fine. Keep in mind that nothing in here has protection, any fuses of any kind, so I'm just relying on the power supply to determine if anything is wrong. If you do build one of these, I highly suggest that you do use some fuses in line with everything to make sure nothing burns up or your projects don't get in trouble. But for my needs, as far as what I'm going to use it for, it's not a problem, just some random bits and bobs. Well, yeah, that's it. Thanks for watching, and see you for the next one.